Okay, I started recording. So we need to represent derivative in different view. And this different view, I hope you remember it, it's dy over dx equals x. When we started to study derivatives, we noticed that dy over dx is just the notion for derivative. But later, in case of differential, we know that we can consider it as ratio. We can consider it quotient. Let's remind you, let's recall what is differential of function. Differential of function, it's dy, it's derivative of function multiplied by dx. And this equation we can write down as dy over dx, so it's derivative. So derivative we can represent and we can write down as y prime, this is the notion, or we can write down as dy over dx. So this equation, these two equations, they are absolutely the same, only different views. Okay, now I will show you how to solve this differential equation. From here, I can write down that, take your paper and pen and write down everything. It's very important. Emmanuel, Muhammad, write down everything.
Okay.
From here, dy, it equals x times dx. X times dx. Is it clear how I got dy equals x times dx? I did multiply both sides by dx.
Hi.
Now I will take integral from the both sides. Integral of dy equals integral x dx. Who can tell me what is integral of dy? Like, what is integral of dx? Integral dx. What is this integral?
Derivative of y.
1.
What, Mohammed? Say again.
Derivative of y.
1 plus
Derivative of y, but it's y. It's y. This integral, it's y. Like this integral, it's x. X plus some constant. So, Emmanuel, derivative of this integral, not derivative, integral, this integral, it equals y. So I can write down y equals, now what is integral of x? What is integral of x?
X squared divided by 2.
Yes, it's x squared divided by 2. Mohammed, do you remember this formula, Emmanuel? Formula for integral of power function. I will write down this formula. Look, integral x to power n dx, it equals x to power n plus 1 over n plus 1 plus c. And by this formula, we have n. In our case, n is 1. So we have x squared over 2 plus c. And this is solution for this differential equation. So in the differential equation, we have derivative of function. And what we should find? We need to find function. And we have just found it. This is our function. And if we want to check, is it correct, our solution? How can we test it? We can plug in this first equation our function, and if we will get x, it means this function indeed its solution. Any questions about it? Any questions about? Look very careful. If any questions, ask me please. Luca, any questions? Luca, no questions?
Sorry, can you scroll down?
Sorry, say again.
Bring it down little. I want to see it.
Oh, okay.
Yeah.
But you should write down it, Emmanuel. You should write down it in your
Yeah.
note.
Yeah. The formula.
Yeah.
Yes. I screenshot already.
Okay. Now, let's give different examples, and I will write down next example. Next example is differential equation dy over dx equals 7 over x. Now start solving this equation to check yourself, and I will follow you. So from here, I will write down dy equals 7 over x dx. I just multiply both sides by dx. Now I will take integral from both sides. Integral dy equals integral 7 over x dx. Now let's recall that constant number we can move out across integral side. So integral dy equals 7 multiplied by integral dx over x. Any questions so far?
No.
Okay. What is next step? What is integral dy? Integral of dy is y plus, not plus, but equal
Equal to
7 times
ln x.
7 times ln
well,
x, absolute value, and plus c.
C.
So this is a solution. Now, let's ask, what do you think? How many solutions have this differential equation? I mean, this differential equation, how many solutions it has? It has infinite number of solutions, because in the our function, we have constant number. And you know, real numbers are infinite, and that's why solutions for this equation, number of solutions, we can say number of solutions, it has infinite number of solutions. Okay. However, we can sometimes we need to find particular solution when given extra condition. For example, let's solve equation dy dx equals x square minus x. So this is a differential equation, and despite it, we have extra condition then that y0 it equals 0,
y 0.
y and in the parentheses 0. It means, Emmanuel, it means that we should first of all, we should find general solution for this differential equation. General solution, I mean, as in the previous examples, we will have there c constant, and then we will use this condition y0 equals 0, and we will find one particular solution. Okay, let's continue. And from this equation dy it equals x square minus x dx. Now I will take integrals dy equals integral x square minus x dx. Now I will evaluate these integrals, or we can say we will find these integrals. Integral of dy, Muhammad, what is integral of dy? It's y. Yes, it's y. As for integral of this function, x square minus x, we can write down it as two integral. Integral of x squared dx and minus integral x dx. This integral we can write down as two integrals.
But sorry, we can take one x out. Yes.
Oh no, Emmanuel, no. It's good question. It's good question, but we can't move out x, because it's variable. What we can move out, it's constant, it's number.
Oh, okay.
Now here we can, this integral write down as difference of two integrals. Like this, look, integral x squared dx minus integral x dx. Now I will continue it, y equals, and I will use again integral of power function, formula for integral of power function, formula for integral of power function, and it's going to be
x cubed divided by 3
x cubed divided by 3. Muhammad, do you agree?
minus x squared.
X cubed over 3 minus x
Cube divided by 2.
x squared divided
Sorry.
by 2 and plus c. This is general solution for given differential equation. Now we need to find particular solution which satisfies this given condition. And let me remind me what was this extra condition. Y 0 it equals 0. And what it means? This 0, this one, it's x. It's x. And this 0, it's y. So I should plug instead y, this 0, I should plug instead y, and this 0, I should plug instead x, and here instead x. And what we will have? We will have that.
Only C.
What we will have?
C.
C equals 0. We will have C equals 0.
Oh.
C equals 0 because it means 0 equals 0 plus 0 plus C. And from here, C equals 0. Now I know what is C, and it means I can now write down one particular solution, and this particular solution is y equals x cubed over 3 minus x squared over 2. So from infinite number of solutions, from infinite number of functions, I choose one particular function which satisfies given condition. And what was given extra condition? Given condition, it was y0 equals 0.
Okay.
Questions, please?
Y0 equals 0 or C equals 0?
Y0 equals 0, it's given. Look up. It's given. And from this condition, we obtained that C equals 0. We calculated it that C equals 0. And
Yes.
graphically, we can imagine it. So this is graph, and this is graph of many functions. Many functions, I mean that C is different for these functions. And from these graphs, we choose only one graph, which is when c equals 0. Now, in the from the next example, it will be more clear. And this example is number 9. I will write down it. So they are given. Write down, please. Dx equals minus 2x e to power minus x square, and given that y0 equals 3. Start solving and I will follow you after 20 seconds. Do you agree what I wrote down?
Yes.
Yes, I just multiplied by dx.
Yes.
Okay. You have to agree also with my next step. And my next step is very simple. I will just write down integral signs. dy minus equals integral minus 2x e to power minus x square also you have to agree because I did not change nothing, only wrote down integral sign to both sides. Now integral dy, it's again y, it's easy as well, but it's more challenging. How can we find integral minus 2x? I missed here dx.
Yes.
We can move out -2.
What, Mohammed? I can't hear you.
Can we move out -2?
Yes, we can move out -2. We can, but there is other question. How it works if we will move out? We will have in the integral x times e to power minus x square. But we have no basic integral to find it. So I think here we should consider to move into differential something. What happens if I will write down here e to power minus x square d minus x square? Let's check. Let's check. Luca, let's check. Maybe it's correct. Let's check. And how to check? To check it.
Maybe we need 2.
Maybe.
Before the integral sign.
Okay, maybe, Luca, but let's check. Let's check. D minus x square, its derivative of minus x square by dx. So that is minus 2x dx. Now compare to our example. Absolutely the same. So d minus x squared is the same as minus 2x dx. And here I have absolutely the same, minus 2x times dx.
Mhm.
I think we don't need no coefficients because they are equal. And if you disagree, please, I am ready for discussion.
No, I agree with you.
Yes, because d minus x squared, it's minus 2x times dx. And
Mhm.
in the previous expression, we have absolutely the same.
Mhm.
Okay, so now let's continue and write down that y it equals. Now I can write down what is this integral because it's basic integral. In the basic integral, I have no here minus x squared, but we can imagine it. They are the same. And we can imagine it as t, for instance, t or z. And what is integral e to power t dt?
T squared divided by 2.
Oh no, Sandro, don't confuse exponential function and power function. I will write down here what I want. Integral e to power t dt. What is this integral?
E to power
E
t.
to power.
It's the same, e to power t. And here we have the same, absolutely the same. If we will minus x squared, if we will imagine as t, here we have e to power t. So here we have e
E to power minus x squared.
yes, absolutely. E to power minus x squared plus c. Now we need to find one particular function which satisfies condition. And what is this condition? This condition is y0 equals
3.
3. Okay. So now what we need to do? Now I will replace y by 3 and I will replace x by 0. And we have 3 equals e to power 0 plus c.
3 equals c. 1 plus c.
E to power 0, it's 1. Sandro is right. E to power 0 is 1. Why 1, Muhammad? Because any number in the power 0, it's 1. And e to power 0, it's 1. So we have from here c equals 2. It means finally our solution for this problem is y equals e to power minus x squared plus 2. Please ask if you have any questions.
Mr. Soso,
Yes.
where did you get these two? C is equal to 2 because e raised to power 0 is 1, and plus c is equal to 1. So is it 1 plus 1 making 2?
Oh, it's very good question, Emmanuel. It's very good question. Okay, let's answer your question. So here we have 3 equals e to power 0. It's 1. Do you agree?
Yes.
1 plus c. So we have 1 plus c, it's 3. And from here, c equals 3 minus 1, and it's 2.
Oh, okay.
3 minus 1, it's 2.
Okay. I understand now.
Any questions?
No.
Okay, let's go forward. Next example. Next example is number 11. And I will write down dy over dx equals 2 over 1 plus x, and given y of 0, it's 5. Let's start to solve. Now I will take integral from the both sides. Integral dy equals, I will write down here integral, and at the same time, I can move out 2 across integral sign. But or I can do it late after one step. 2, 1 plus x dx. So integral dy, it's obvious, it's y equals 2 times, and what can we do here? Here we have Luca
Dx over 1 plus
1
x.
plus x. Yes, we have no basic integral like this, but instead dx, we can write down d 1 plus x, because they are equal. What I did use? I used the d 1 plus x, it equals derivative of 1 plus x. And what is derivative of 1 plus x? It's just 1.
Yes.
So derivative of 1 plus x, it's 1, and it's dx. So I replaced this dx by d1 plus x. But why I replaced? Because I need to integrate it. And to find this integral. Oh. Okay, now let's continue. Here we have y equals 2. What is this integral? d 1 plus x over, oh, I made the mistake. Could you notice the mistake?
In the denominator?
Yes, absolutely. In the denominator, we don't need d. There is just
Yes.
1 plus x.
Yes.
Got it, Sandro?
Yes.
There we have just 1 plus x. What I changed there? I just, instead dx, I wrote down d1 plus x. And also, I don't need these parentheses. Okay, now what is this integral? d1 plus x over 1 plus x. It's basic integral. It's close with basic integral. But we need some imagination. What imagination we need? We need to imagine that 1 plus x
So
is
it's
t, or yes, t, integral dt over t.
It's ln x.
ln t, it's ln t. So here we have y equals 2 times ln 1 plus x plus c. Any questions?
No.
Okay, one more example and then we will take break. This example is integral dy over dx equals e to power x minus 3 and y3 equals minus 5.
sorry. What was the previous answer?
In the previous example, Luca,
Yes.
just a minute.
You
Just a minute. I will
I
check.
want to check, and so I'm
Okay.
asking this.
Okay. Can you see?
Yes, I see that, but the answer was we have to find the equation when e0 equals
Oh
5.
yes, yes. Thank you, Luca, very much. I missed this condition. Okay. So okay, thank you very much. And now we need to find one particular function. And to find this particular function, now we will use this extra condition. And what is this condition? Can you tell me, Luca?
y
Y of 0,
Yes,
yes, y of 0 equals 5. Y of 0
yes.
equals 5. Okay, so it means y I have to replace by 5 and x I have to replace by 0. So we have 5 equals 2 times ln 1 plus 0 plus c. Now what we need to know, we know very well 1 plus 0 is 1. But what we need to know, what is ln1? Let's recall ln
E
is,
to power
what is ln? Ln is logarithm with base e, with base of Euler number.
yes.
So what is, for example, what is a logarithm with base e1?
0.
Yes, it's 0.
Yes. Sir.
It's 0. Why? Because it's 0. Because logarithm.
Because every real number in power 0 is 1.
Yes. So remember, I would like to ask Mohammed to remember very well that always ln1 it's 0, and not only ln with logarithm with base of Euler number, but with base of any number. Logarithm of 1 it's always 0. Okay, so here we have 5 equals 2 times ln1. 2 times ln1. 2 times ln1 is 0. So 2 times 0 plus c. And what it means? It means that c, our constant, is 5. C, our constant, it's 5. So now I can write down finally that our particular solution, particular function, is y equals 2 times ln 1 plus x
Plus
plus
5.
5. Any questions?
No.
Okay. Take break for 10 minutes.
Okay.
And let's meet again 8 p.m.
Mr. Soso,
Yes.
we're supposed to have 1 hour, right?
Yes, 1 more hour. Yes.
Okay, 2 hours total.
Yes, absolutely.
Okay.
Okay. See you soon.